In this section, we're going to compare and contrast the domains and range of each of these functions. All right, so let's start with the first exponential function. Domain remembers about how far left to right the function moves, and this one moves forever left and forever right. So since it moves forever left, that's negative infinity, and it goes to forever right, which is positive infinity. Interval notation, you list that as negative infinity to positive infinity, and in set notation, you'd say all reals, which if you wanted to shortcut that even a bit, you could just write the double bar r, which means the same thing. Alright, range is about the up and down, and if you look basically the range for this one, it kind of bottoms out at 3 but goes up to forever to infinity. Let me see if I can draw that line a little straighter. So it never quite reaches negative 3. Not sure if that was much better. Okay, so the range, it is everything from negative 3 to forever. So in interval notation, you write that as an open bracket, negative 3, comma, infinity, and I can't use a square bracket because it doesn't actually reach negative 3. In range and set notation, you just say that y, or f of x in this case, I guess, we'll write it either way, f of x is simply greater than negative 3. That means everything above negative 3. You could have also gotten away probably with writing y is greater than negative 3. Either one of those would have been fine. Alright, now let's try the next one. On this function, we have a quadratic that, even though it's moving up really fast, it's still continuing to move to the left forever and move to the right forever. So it moves from negative infinity to positive infinity again. So interval notation would suggest that the domain of this is negative infinity to positive infinity. And if I wrote that, I could say all reals if I wanted to write set notation, which is a double bar r. And the range on this one it bottoms out, it looks like at negative 4, and with a quadratic it actually reaches that negative 4. It touches it just perfectly. So the range on this one would actually be a closed dot from negative 4, and range is all about up and down, so it's the y value, and all the way up to forever. So in interval notation, we would write that as a square bracket negative 4 because it actually does reach the negative 4 all the way up to infinity. Or in set notation, we would say f of, well, take that back, g of x, again you could use y or g of x, is greater than or equal to negative 4. Alright, and this last one is a line, and it goes forever left and forever right. So again, domain is everything from negative infinity to positive infinity, from left to right, which is all reals. And the range is it goes down to forever. In this case, it keeps going down forever and it keeps going up forever. So this one is also negative infinity to positive infinity. And again, in set notation, you'd write that as all reals. Alright, so now we've got to kind of feel we can use these functions to help us maybe if we need help with answering things about each of them. This time they gave us the equation or the function, but they didn't quite give us a graph, but a little space to graph it. Alright, so I can already tell this is going to be a quadratic that has been moved, the vertex has been moved to the right 1 and down 3. Let me show you where I got that from again. So that would be positive 1 because you changed that sign, and negative 3. So the vertex is to the right 1 and down 3. So that would be where the parabola starts. And this has been vertically stretched as well by a factor of 2. So it's over, basically over 1 up 2 and left 1 up 2. And so we'll have a parabola that looks something like this. Alright, so let's start with the domain again. The domain is forever left and right. So I think the domains pretty much for all these functions is going to be pretty consistent. You're usually going to write negative infinity to infinity, and in set notation that would be the same as writing all reals, which is a double bar r. The range, however, is going to be different for each one. Like this one bottoms out at negative 3 and goes up towards forever to infinity. So the range on this would be from, it's a square bracket because it's a parabola, so that would be a square bracket including the negative 3 because the vertex actually gets down to the negative 3 and goes on to infinity, which would be the same thing as saying in this case m of x is greater than or equal to negative 3. Alright, the next one we have is going to have an asymptote because exponential equation or exponential function, so it's going to have an asymptote at 1. That I should say y equals 1. At y equals 1, and if you graph this with your calculator, or graph it any which way you'd like to, and plot some points, like for example, I could put 2 to the 0. 2 to the 0 would be 1, so that'd be 1 plus 1, and so that would be 2. So when I put 0 and I get a 2 out, so 0, 2 would be one of the points. Let's try to put 1 in to see what the point would be if I put 1 in there. So 2 to the first plus 1, so I'm putting 1 comma something. So 2 to the first is 2, 2 plus 1 is 3, so the next point would be 1, 3. And so I hope that's enough to kind of see you're going to have a exponential graph that looks something like that. Alright, domain as it has been for all of these problems is it moves forever left and forever right. So once again, negative infinity to positive infinity, all reals. And then it does kind of reach a point where it levels out at 1 and goes up to forever. So I'd write this as from 1 to infinity, because this up and down part of that graph only starts at basically 1 and goes up forever. And that would be f of x, or p of x in this case, is greater than 1. You're just looking at the up and down possible values. Right, the last one is a line. And if I graph this one, it starts on the y-axis, or the y-intercept is negative 4. And it has a slope of 2 over 1, which is rise 2, run 1. So if I rise 2, run 1, I can plot the rest of this. Rise 2, run 1. So you can see it just makes a straight line that goes something like this. And as it has for every one of the problems we've done previously, it goes forever left and forever right. So once again, negative infinity. I don't think I even wrote that on my graph this time. To infinity, which is all reals. And it looks like it goes up and down forever as well. If you look carefully, this one goes, keeps going down and it keeps moving up. So this would also be from negative infinity to infinity, which is all reals. Alright, so hopefully getting the hang of this. Let's look at a couple more now that we have this idea of what's true about these types of functions for the most part. It says, which one of the functions, let me kind of make this a little smaller so we can see it. If we only consider the functions linear, quadratic, and exponential, which is the only function that could have a range of negative infinity to infinity. So that means it's going up forever and down forever. So specifically asking us to look at just the range. So if I look carefully up here, the only range that seems to go up and down between those three is linear. Right, let's look at the next one. If we only considered the functions linear, quadratic, and exponential, which is the only one that could have a range of 2 to 8. Now it's really important that you notice you use a circle bracket, meaning not included. So that's the only time we had a circle bracket for the range on both sides, which that would be basically exponential because it did not include the 2. Alright, and the last one says, if we only consider the functions linear, quadratic, and exponential, which is the only one that could have a range of negative 5 to infinity, including the negative 5. So the square bracket, it looks just like that one. So this would be a quadratic. Alright, I hope this was helpful. Good luck on your quiz, and ask your teacher if you have any other questions.